Dr. Tishan. In this video, we are going to find volume of solids by using known cross sections. The formula for finding the volume of a solid, all we have to do is we have to integrate the area formula of our cross section. That's what we have to do. So we're going to have to take the dimensions of the area formula and write them in terms of the functions that we are given. So we're going to find the volume using known cross sections that are perpendicular to the x-axis. We're also going to do an example when the cross section is perpendicular to the y-axis. We'll do these three examples here. So let's take a look at example number 1. Example number 1, our base is going to be x squared, and then so the parabola y equals 0 and x equals 3, and we're going to use squares. And so just to give you a little idea of what this looks like, and this is just going to be a quick rough sketch, okay? So I'm going to draw, here's my y-axis, here's my x-axis. All right, I'm going to just sketch this base really quick right here. I'm just going to sketch y equals x squared from 0 to 3. All right, and so this is like our shaded region right here. This is our base of the cross section. And we want to, for this one, we're going to put squares in perpendicular. Every square will be perpendicular to the x-axis. We want to put infinitely many squares in here. So the squares that are close to the origin are going to be little itty-bitty small squares, okay? Because there's the length of the side. All right, and then as we move closer and closer to 3, you can see that the squares are going to get a little bit bigger and bigger and bigger. So, I mean, as we get closer and closer to 3, you can see the squares are going to get bigger and bigger. And so by the time we get over to 3 over here, all right, we draw our little square in here, you should be able to see that, so, you're going to have a shape of maybe like a ramp. I know this is a really, really crazy rough sketch, but probably the shape of a ramp. So what we're doing is we need to form this solid, right? If you want to find a volume of an object, it's got to be a 3-dimensional object. So we're using a 2-dimensional plane to represent the base of the solid, but then to make it 3 dimensions, we're going to insert infinitely many shapes in there, okay, cross sections in there. And so for this first example, let's use squares. So how would we sketch, because we're going to sketch each diagram, then we're going to write the equation out for ourselves, and then we're going to compute it. So how would we start by sketching the diagram? Well, I would say sketch the base, definitely give a sketch of the base. So we know y equals x squared from 0 to 3. This is what our base is. Y equals x squared is the parabola up top. Y equals 0 is the x-axis up to 3. So here is our base right here. And then just maybe put one slice of your cross-section in there. Put one slice in there and label the dimension of your cross-section. So for this example, we're using squares, okay? So I'm going to put one slice of the square. Hopefully that looks like a square to you. And then this is the length of the side. I'm going to label an S for the length of the side of my square, okay? So here's my cross section right here. It's a square, and I labeled the side of the square. So we want to find the volume. So to find the volume, we're going to integrate from A to B. Okay, the area formula of our cross section. Our cross section is a square. So what is the area of a square? Take the length of this side and square it. Okay, but we're not ready to integrate yet because we have to take the length of the side and write it in terms of the functions of x. We have to write it in terms of the functions given to us, okay? So let's go ahead and do that. Let's set it up given our base and our diagram here. So the bounds of integration along the x-axis around your shaded region. So 0 to 3 for the bounds of integration. We want to take the length of the side. But we have to write it as a function of x. So let's take a look at the diagram. Look at the height, the length of the side of your square here. Side goes from the x-axis to the function. It goes to the function, and you're going from 0 up to the function. So what is that height going to be? It's just going to be the function. Okay, you're going from 0 to x squared. So what is that length of the side going to be? It's going to be x squared. All right, so it's just going to be x squared. And so then we just go ahead and do the integration and evaluate. So when you integrate, this is x to the 4th power. When you integrate x to the 4th power, you're going to get x to the 5th power over 5, and we want to evaluate this from 0 to 3. All right, and when we do that using the fundamental theorem of calculus, plug in your upper bound, so you have 3 to the 5th power, that's 243 over 5, and then plug in your lower bound. When you plug in your lower bound, you have 0 to the 5th power over 5, which is 0. So your final answer here will be 243 over 5, and there's your answer to the first example, okay? So finding the volume of a solid using known cross-sections, what you need to do is we need to integrate the area formula of the cross-section. If your cross-section is perpendicular to the x-axis, we drew it perpendicular to the x-axis, then you're going to evaluate everything in all your cross-sections in terms of x, okay? Now, when it's perpendicular to the y-axis, we'll be addressing that in a moment, but perpendicular to the x-axis, you just draw your diagram and then compute everything with respect to the x-axis with respect to x, okay? Let's look at example number 2. Now, example number 2, y equals x squared, y equals 0, and x equals 3. We've got the same base going on, same base, but let's take a look at what happens when we use semicircles instead of squares, okay? So let's take a look at this one with semicircles, all right? So here's my y-axis, here's my x-axis. I'm going to sketch the diagram, all right? So here's my diagram, all right? And it goes from 0 to 3, and this is my base right here from 0 to 3. It's the parabola, all right? So you've got your parabola and you've got your x-axis. We want to draw one slice. We're going to draw one slice, so my diameter of my semicircle is sitting on the axis perpendicular to the x-axis, so my diameter, and here is my one slice of my semicircle. Here's my one slice, okay? I'll label the radius in a moment, okay? And you might be able to see what's going on here, but we want to find the volume. So we want to find the volume. We're going to integrate from A to B the area formula. We want to integrate the area formula. So what is the area of a semicircle? Okay, the area of a circle is pi times radius squared. So the area of a semicircle is going to be half of pi times radius squared. That's what your area of your semicircle is, all right? We need to take the area of the semicircle formula, and we need to take the dimension and write it in terms of x, in terms of the functions given to us. So let's go ahead and fill out the bounds and fill out the integrand here. The bounds of integration along the x-axis around the shaded region, 0 to 3 again. I'm going to call this constant here pi over 2. We need to take the radius and we need to square the radius, but the radius has to be written as a function of x, as a function of x. Now, we have the diameter sitting on the base, right? Look at our semicircle here. The diameter is sitting on the base, and so how is the radius related to the diameter? What's the relationship? Well, the radius is half of the diameter, isn't it? This is my radius right here, okay? So I'm sketching the radius here in blue. All right, here's my radius, okay? So what is the radius? What do I have for the radius? Well, it goes from the x-axis halfway to the function, okay? So if we went all the way up to the function, like the square did, that was x squared, but this is only going halfway. So what is the length of my radius? It's going to be half of x squared because it goes from 0 halfway to the function. So be careful with semicircles. Just be careful because you just take the dimension, whether you're using squares, semicircles, equilateral triangles, right triangles, rectangles, whatever shape you're using, you got to look and write the dimensions in terms of the given function. All right, let's go ahead and compute this. Now I have pi over 2, and I have another constant here. The 1/2 is being squared though. Okay, see the 1/2 is being squared, so square the 1/2 gives me 1/4 times pi over 2, so there's pi over 8, isn't there? Okay, and then I'm going to integrate x to the 4th power, so that's going to give me x to the 5th over 5. I'm doing the integration here, and now we're going to evaluate this from 0 to 3. Okay, so we'll evaluate this from 0 to 3. I'll leave a constant out front, and I'll just evaluate this part from 0 to 3. Okay, so what do we have for our volume here? We have pi over 8. Okay, and then when we evaluate x to the 5th over 5 from 0 to 3, you're going to have 243 over 5 when you plug in. Okay, so 3 to the 5th power, 243 over 5 minus 0 to the 5th, so that's going to be 0 over 5. So when you compute this, what do we have here? 243 times pi is what's in the numerator, and the denominator 8 times 5, so we have 40 in the denominator. 243 pi over 40 for this answer here. Okay, so here's this answer. All right, so this is cross sections when you have cross sections perpendicular to the x-axis. Perpendicular to the x-axis, then we will actually write everything, do everything in terms of x. Okay, what happens when your cross sections though are perpendicular to the y-axis? Let's take a look at this. All right, so let's go ahead and sketch our base. Our base is y equals 2 radical x. All right. So here's my x-axis, here's my y-axis. So 2 radical x, okay? So this is 2 radical x, and then y equals 6. Okay, so y equals 6 right here. Okay, so they're going to come into contact somewhere over there. This is our base right here. Okay, all right, so our base is going to be 2 radical x. 2 radical x is the bottom piece here. Y equals 6 is my horizontal line right here. This is y equals 6. All right, and x equals 0 is the y-axis. Okay, so you can see that it gave me the boundaries, it gave me the bottom piece and the top piece and the side. So there's my shaded region. I want to draw, what do I want here? Rectangles perpendicular to the y-axis, okay? Rectangles perpendicular, so when I draw my slice in here, my rectangle, I've got to draw it so it's not perpendicular to the x, but perpendicular to the y-axis. All right, how do I find the area of a rectangle? It's base times height. So here is my height, okay? And then so my base, it says, is 3 times my height, okay? So my base is going to be 3 times my height. So this is my base here. And there's my height, okay? And we want to find the volume, all right? So we want to find the volume. So to find the volume, okay, we're going to integrate from C to D, all right? And it's going to be my height multiplied by my base. But I have to write this in terms of y. When your cross sections are perpendicular to the y-axis, then you need to write your expressions in terms of y. You need to integrate with respect to y, not with respect to x. So we're going to need to change around our equations here, okay? Everything in terms of y. And what do we integrate? We integrate the area formula of your cross section. What is the area of a rectangle? Area of a rectangle is base times height. So that's what we're going to integrate. What about the bounds of integration here? The bounds of integration are going to be along the y-axis. Look at the y-axis, 0 to 6 for the y-axis. Your bounds of integration 0 to 6, okay? What do we have for the height? Well, let's work that out over here, okay? What do we have for the height? Let's come over here and work that out. We have y equals 2 radical x. All right, that's what we have. This is y equals in terms of x, but we need to write in terms of y here. So we're going to have to solve for x equals. So let's go ahead and divide both sides by 2. Divide both sides by 2. So radical x equals y over 2. And I don't want radical x, I want x. So square both sides. X equals, it's going to be y squared over 4. Square both sides. Okay, this is what I need to use here. Okay, so now what is my, all right, so what are the dimensions? Height times the base. Well, what is my height? Okay, my height, it goes from 0 to the function. So my height goes from 0 to the function, just as we did over there. My height is going to be the function, but you got to make sure that you're taking x in terms of y. So the 2 radical x is my function, y in terms of x, but when I rewrite that and write it x in terms of y, it's y squared over 4. So my height is going to be y squared over 4 because it goes from 0 to the function as we write it in terms of y. Then what do I do for the base? Okay, what do I do for the base? Well, it tells me up here my base is 3 times my height. Well, if my height is y squared over 4, then what is my base going to be? It's going to be 3 times y squared over 4. That's what it's going to end up being, okay? So because my base, they have to give me information about it. The rectangle has the 2 different dimensions, base times height, right? Look at how it differed from your semicircle. You only have the 1 dimension. We only have the radius, right? It's 1/2 pi times radius squared. Your square only has the 1 dimension. So you could just figure out the dimension based off the curve. Semicircles, you can figure out the dimension based off the curve, okay? But what about the rectangle? Well, there's 2 dimensions here, so we can figure out one of them based on the base, okay, on the diagram. But yeah, they had to give you some information about the other one, okay? So we're going to integrate from 0 to 6, okay? So 3 times y to the 4th over 16 dy. There's your integrand, okay? Now, instead of doing this by hand, I haven't used the technology yet, okay? So probably possibly you're using some technology in your calculus class. We are, because we're in the application of the integration, so letting the students use the technology here. So we use the TI-89, okay? So if you want to take a look, pull out your TI-89, and let's type this one in just for sake of just practicing with the technology. So for our calculator, you're going to hit the F3 button. We're going to choose number 2 because we want to integrate, okay? And then, so what is our integrand? It's going to be 3y raised to the 4th power, all right, and that's over 16. That's what my integrand is, okay? So it's 3y raised to the 4th power over 16. I want to integrate that with respect to y from 0 to 6, and then close parenthesis. Before we take the answer, we should just check and make sure we typed it incorrect, okay? So 0 to 6 for our bounds of integration, 3y to the 4th over 16, and did that in terms of y. So what do we have here? 1,458 over 5. 1,458 over 5 for this answer. So 1,458 over 5. Keep saying it to myself so I don't forget the pieces there. So here's the answer. You know, and it's not, I mean, it's not difficult to do by hand either, with just using the power rule of integration. So, okay. So this is the, hopefully this gives you the idea of how you would address finding the volume using known cross sections, right? So all you're doing with these cross sections, all you're doing is you are just going to set up a definite integral using the area formula for the cross section, okay? So whatever the area formula is, if the area, if you're using squares, then you're just going to integrate the area formula of a square, but write it in terms of the functions given to you, okay? If you're using semicircles, if you're using right triangles, equilateral triangles, if you're using rectangles, whatever you're using, write the area formula in terms of the functions given to you. If your cross sections are perpendicular to the x-axis, then you're going to work it out in terms of x, okay? When your cross sections are perpendicular to the y-axis, all right, then you need to maneuver things around and you're going to actually set it up and integrate with respect to y, all right? Okay, whew. Hope this is okay for you in terms of cross sections. Hope it helps. I would love if you'd subscribe if these videos do help you. I would appreciate that very much. Take care. Thank you for watching.